Lucky last talk for this afternoon. I think this is an IGMES special issue paper, yes? So we have Don, we have Anthony, we have Anita, and we have Alison talking about diagnosing readiness. So lucky last talk for this afternoon. I'll hand over to who? Don.
I think we just bypassed the having to introduce ourselves. So yeah, our topic is diagnosing readiness, looking at the transition to higher education and the issues that students have in that transition, how we can help to perhaps smooth that over.
So really the challenge is that mathematical preparedness is really a barrier not only in access to, but also within higher education. So it's sort of a double-edged sword. So not only do you need to be highly prepared to get admissions to higher education, but once you're there, you need to be successful to have access to certain colleges, programs, degrees, or to just even progress within your own college program or degree. And so it really is a hefty barrier for many students. So when we think about students transitioning to higher ed, that sort of mathematical preparedness becomes a formidable obstacle to success and achievement for whatever it is that they desire to do in higher education. And so sort of 4 factors, this is not an exhaustive list, but sort of 4 things that we highlighted is measuring preparedness. So different institutions, different countries measure preparedness differently. And so this is very difficult for students. So depending on where they are, what country, what state, what type of university they're attending, what the entry level of mathematical preparedness expectation or how it's even measured varies wildly. And so this is problematic. There's not sort of a standard norm of what is mathematically prepared. We also have inequitable access. And so social economic factors weigh heavily in the amount of exposure and the quality of that exposure to mathematical preparedness in secondary school. So as students are transitioning to tertiary, whether or not they had really well-prepared teachers, good access to high-level mathematics within their school, but also access to those sort of activities where they might synthesize the mathematical learning outside of the classroom is also something that's dependent on sort of socioeconomic and wealthier communities. Learning loss. We used to sort of not joke, but worry about learning loss over summer vacation in our country. But then the pandemic really put that in a whole new perspective, right? When we're thinking about learning loss. So whether it's summer vacation, gap years that students take, or just a lack of sort of continuation of progression within the mathematics, or they take statistics their last year of secondary school before coming to higher education. So learning loss can really come in different ways, or if they happen to change majors during their tertiary experience in higher education, there can be learning loss there as well. We also see passive learning. So I think about in Jess's talk this morning, she sort of touched on many of these things. But when we think about students using technology, using AI, or the faculty, the delivery of the calculus that she talked about, where it's still very lecture-driven, how do we bring that sort of active learning back into the environment for students? There's a lot of research saying that that active learning is really important. And so not being actively involved can then lead to preparedness gap in students' experience and their learning as they're progressing up the curriculum. Now I'm passing to somebody else.
Let me. So the solution that we're looking at for this is the use of adaptive diagnostic testing. Diagnostic testing is certainly nothing new. It's been used for years, but one of the issues with it is either you present a test which just analyses the level that you want the students to be at. So you give a series of questions at the level that you expect the students to be at. If they can answer all those questions, great, they have the skills that they need to move into your course. If they don't, well, you don't really know where they are. Or you give some very long test that tests their mathematical ability going from very basic levels up to more advanced. And that can take a long time. So using adaptive testing, you kind of get the best of both worlds. You have a test which has an underlying knowledge map, which that picture is a part of for one that I've been developing for UNSW. And once you ask a student a question, if they answer that question correctly, then any question in the knowledge map which is below that, which is essentially knowledge that's required to answer that question, you mark it as correct. If they get the question incorrect, then any question that's harder than that question or that uses that concept in its requirements, you mark as incorrect. And so you can get through all of the questions in the map by only asking a fraction of the total number of questions. So it gives you a very personalised result for each student. You know fairly well whereabouts their level of knowledge is, and you can, based on that, then present pathways for them. If you need them to have particular levels of knowledge, then based on the knowledge on the diagnostic test, you can then prepare a pathway for them to build up the skills that they will need before they get into their first course. And there's also research that shows that improves their retention, degree completion, and it can be used for placement, particularly in Alison's case. So I think I've probably just talked about all of the things that are on this slide. So by using the diagnostic test, students can be slotted into the right courses, into a course where they're more likely to pass. We all have students who take harder or come into a first year course and then fail it, and then fail it again and fail it again, and end up extending the time that they need to study. So if we can slot them into the right course, we give them better outcomes. Having passed a course is obviously helps retention and helps their engagement. So we get higher retention, hopefully fewer failures because they've come into the right course, and graduation in a more timely fashion. And that also leads to more stable course rosters. So early placement means that we have a better idea over time of whereabouts those students should be going. And it also helps us with research. We collect a lot of data from these adaptive tests that can then be used to address how students learn, what are the holes in their learning overall that we need to look at.
Thanks, Don. Okay, so we basically got together last year in Anita's beautiful home in Cape Town, South Africa, because we'd all been doing some version of diagnostic testing or adaptive diagnostic testing. So we put on this day in Cape Town, and we kind of invited people to get involved, and we had Zoom participants and we had in-person participants. And really, like Don said, diagnostic testing is not new. There's a lot of work, especially in the UK with Duncan Lawson in the 90s, and I think Mark built on it as well. And it was used for different reasons, to show maybe that standards had dropped in the UK with A-levels, also that students come to university maybe aren't as prepared as we liked. And we kind of felt it was time to bring it back. Okay, so it might not be as fashionable, and we should say that we don't really call our tests diagnostic tests. We don't use the medical language of you're not well mathematically, you need to get better to do these kinds of things, but just for the purposes of research and what's been written in the literature, it's usually called diagnostic testing, and there's a nice paper about diagnostic testing, what next? So really, we're not just talking about testing students and telling poor students that they're poor, we're trying to get them into the right placement and get mathematics support for them through our various mathematical support services. So at Illinois, then, that's Alison's institution, Urbana-Champaign. She has a large cohort of undergraduate students, and she's been working there for many years and working with the system Alex, and that places students, and she's done a lot of research on that, and it's really fine-grained research. She can look at particular comments, particular topics within courses, and that can be really predictor of where they go from college algebra to calculus, pre-calculus, calculus 1, and so on and so forth. Then my own college, University College Dublin in Ireland, we have a large cohort of undergrads, and I was lucky enough to have a PhD student for the last 4 or 5 years. She started when COVID started, so we felt we had to do something in terms of these students who had their secondary school affected so badly. So we came up with this idea of Maths Fit, which was a diagnostic test basically, it was at what we call the junior certificate level. So about in Ireland, it's the exam you take at about age 15, but these were coming to university and we were worried about them and our worries became true. So we kind of had to do something. So we tried to use the VLE, the virtual learning environment, to email them in terms of their scores and tell them they should come to the Math Support Centre or else watch this video or else engage with this PDF. And a big buy-in there was that 4 of the lecturers involved, these were large classes, so I think it was about 1,700 students. The lecturers involved allowed us to use a small part of their course, continuous assessment, in the diagnostic test. So again, it wasn't really to penalize students. They had 2 attempts at it. So I think once they took it at all, they got 1 out of 3%. And if they re-engaged with it, chances are they got 2 or 3% on the second time. Then University of New South Wales is Don's university. And Don has done a lot of work with his previous university in Western Sydney. And that again has UNSW has a very large cohort of undergrads. And Don has been excellent in terms of using with Jim, I think he was here, using the free open source tool Numbers, which is UK based, and Don writes really excellent questions, and we've piggybacked on those questions. And why they're excellent is it's the feedback. So I think a lot of the work goes into the feedback that you do. You parameterize questions, you randomize questions. Therefore, the feedback also needs to be parameterized and randomized. And then finally, Anita is in the University of Cape Town, and you're kind of your institution is responsible for the national benchmark tests for the entire country, and that gives you a good barometer of where students should be and where they're going. And she has started to use diagnostic testing as well in the last year or so. So I think Anita and I are a little bit less experienced than Don and Alison in this. What's next, Don? I can't remember. That's over to Alison.
Back to me. So we implemented Alex, which is assessment and learning and knowledge space, back in 2007. And we were the first institution in the US to use this type of diagnostic, and it was widely unpopular. That being said, we have continued, and we've now had over 150,000 students on our campus use this assessment. So that's an enormous database. And over 250 institutions in the US have copied our model of what we've done. The important thing about what we did with our diagnostic is this is post-admissions. So we've already admitted these students. They're already agreed to come to campus. And so the primary goal was to help students be successful and also for us to really have that granular information. Our incoming student population is amazingly dense in terms of their knowledge space. So how do we fine tune what supports need to be there? Those just-in-time learning things that we might insert in into the curriculum. And also have more information about what we do as sort of the diagnostic also driving curricular changes on our campus. So not only is it individualized for the student and adaptive in terms of that initial assessment, but it also gives a personalized learning plan. And so I always think about it as being an awesome bucket of spackle, because they all come in with different holes and gaps and cracks in their background. And so this sort of just fills in those holes in the background for us, for the student, to make sure they're up to speed to be successful in their class. And so again, the entire intent is really to help them be successful. We then take that assessment, which every incoming student has to take. So our incoming class, just over 9,000 students. Everybody has to take it. It is required. But then if you're going to enroll in certain courses where historically we had high non-success rates, sometimes 4 times the campus average, talk about a barrier within campus to being successful. If you fail your first math class, you really are not going to succeed very well that first year. It makes it very difficult for you. And so how do we then make sure that we're placing students into the right class to help them be successful? And then continuous institutional research. 2007 was a long time ago. It seems like yesterday in many ways until I look in the mirror. And so when we think about students going through that progression, are we still seeing the same outcomes? Are students still be successful? Do we need to change our curriculum? Do we need to look at post-pandemic, pre-pandemic, now with AI in terms of what's happening in the classroom? So back to Don's point, the diagnostic is not only there to help students be successful, to identify strengths and weaknesses, to build the support, what's next for students, but also for us to self-reflect on what we do as an institution, what we do in our classes, and how we make good curricular decisions to help students on campus. And so really we wanted to address that challenge, particularly in the US, because there's no national curriculum There's not even a statewide curriculum. There's not even a district-wide curriculum all the time. So students really have very widely different mathematical experiences. So how do we bring them together to be successful? Because you're going to be taking the same exam with the person sitting next to you in class, and it's really a different experience for many students. So how do we help students be successful on our campus after having very, very different preparation coming into our higher education system in the US?
Thanks, Alison. Yeah. So the situation in Ireland then is that every student who is educated in Ireland, secondary school or high school, must do mathematics up until their leaving certificate. That's the final state terminal exam. So in some senses, that's good. We're forcing students to do maths until the very end of their secondary education. But at the same time, they're not aware of maybe the mathematical challenges that are in a computer science degree or in an engineering degree. So there's a job of information there. So a big challenge for us is that the Leaving Certificate results come out at the end of August and university starts at the start of September. So there's not a whole lot we can do. We have week 0, which is the orientation week, and even then we're not getting all the students because students get accepted on second round offers, third round offers, fourth round offers. So some students might start in the university until halfway through. So this diagnostic then that's run in week 0, which was run by my PhD student Claire Mullen, she made videos which were kind of welcome to the university. This is Maths Fit. It's just a snapshot in time to see how you're getting on. We want to prepare you as well as we can for your mathematics courses. And we ran it for 4 courses, the 4 big service courses that we deliver, which are science, engineering, agriculture, and business. And again, there were 4 different tests. Obviously, commerce students, business students don't really need trigonometry, so there was no trigonometry in their diagnostic test. Engineers would have a higher level of mathematics, so that diagnostic test was a little bit more challenging. And then the VLE, as I said, uses the intelligent agents to feed back to the students within an hour of them taking the course. It tells them you've done poorly in trigonometry, you've done well on calculus and functions or whatever it is, and it goes granularly into each subsection, and it can point them to videos on that subsection that are either created by the Maths Support Centre or whatever we got off the web for Creative Commons. So the big thing is trying to get the students to engage with us in the Maths Support Centre. So physically come in and talk to a tutor. This is actually CJ here giving a hot topic to 4 of the students that came in from Maths Fit. So these might not be from the one class, but they might all be struggling with functions and calculus or whatever it is. So we might have 4 students there from 4 different courses, but they're all studying the same mathematics. And it's not that contextualized in the early weeks, at least, so we can get the basics across to them. So then the idea was we just ran it with COVID, we tweaked it. Claire did lots of interviews with the students. What did you think of the diagnostic test? What did you think of the fresher course materials? And the students came back with lots of good feedback. One of the best pieces of feedback was the lecturers themselves didn't like the idea of Maths Fit being advertised throughout the semester on their Blackboard space or Brightboard space. That's our VLE. But the students wanted it there. So it was nice that the students wanted to be able to go back to basic stuff when they were struggling maybe in week 6 with whatever it was, matrices or whatever, and they had that resource to go back. So we went back to the lecturers and said, students are looking for it to be unhidden on the VLE. Can we do that? And the lecturer said, yes, of course. So that is something that we've kept going. So the Maths Fit is there and it doesn't fall down as the weeks go on. It's there at the very top kind of the module page. So yeah, we looked at a lot of data and it's in Claire's PhD if people are interested, and there's some papers published on it. So we've seen that students from maybe the lower socioeconomic backgrounds, students from who don't have English as a first language, certain other minorities do well out of this, provided they attend the Maths Support Centre. So we can't really say much about the diagnostic test as being a predictor for the final exam because it's such a small weighting, but it's the attendance at the Maths Support Centre, which is really a follow-up to their score on the diagnostic test that can be effective.
Yeah, but I'm going to have the big wrap up. But Don is the expert on the USN W section. But I see we're running close to time, and we do want to leave some time for questions. So I think a fair amount of this we've already spoken about. Just to mention that at my university in Cape Town, we're sort of the latecomers in terms of the development of the 4 cases that we've been looking at. And we've had over the last 2 years some trialing of Alex, which is great, but jolly expensive. And while Alison has had nearly a couple of decades now in integrating this into the costing of university. This is a big drawback for us. So I could just say that we are looking at what free resources can we develop so that we could offer, now that you've got your diagnosis, what next? So that's the next big challenge that we're facing.
Thanks. So UNSW, we're still developing a diagnostic test. It's been pushed along by the Australian government's aim to have 80% of Australians have some sort of post-secondary education by 2050. And so the university is being pushed to take a greater diversity of students with greater range of mathematical abilities. We've developed this numbers diagnostic test, which numbers have developed a diagnostic algorithm that works along the lines that I spoke of before. It's now been trialled for 2 terms with Math 1131 that Sean was talking about earlier, and also been trialled at the University College, which is the preliminary college for the university. And we've had a lot of help from them in the development of it. And we're now getting asked if we can have diagnostic tests for the School of Business and Med Science, where they have slightly different maths requirements. So this idea of using the diagnostic testing is moving to other areas of the university, but it's very much something that's in motion rather than something that we've finalised.
Right, so maybe just look at these final 6 points. See which is your favorite that you want to chat to us about at tea time. So we've got validity and reliability, institutional fit, making sure that it works for your context, the need for having very clear policies, ensuring stakeholder buy-in. It's admin and boring, but it's crucial. Timely assessment, whereabouts do you do it? Like for Anthony and I, we have a short time between students getting their school leave-in results and when university starts, which would be the ideal time, but there is no time. And offering targeted support with the right kind of resources that you can muster in our financially constrained context.
I think we're actually talking about trying to make this available to students before they finish their school education so that they can have a better direction of where they're going. And potentially that's also a marketing tool for the university.
This is going to be me because the next slide is inviting you to come to Cape Town. So yeah, one you can go.
The email addresses are here as well.
So last year we ran a little workshop on diagnostic maths education or testing so that we could start the rumblings. And over this last year, I've really felt there's the greatest need is for us to work with our team who developed the national benchmark tests and follow on. So as a student gets their results on their national benchmark test, which is a kind of diagnostic test, it's not compulsory, but most universities require it somewhere along the line. But so what is the big problem? And that's going to be part of what we will explore in the workshop, apart from looking at numbers and what resources that are out there work in our context, but perhaps you want to add your continental or country or university spin on that. Thank you very much for your attention. We have 1 minute for questions, but we do have tea time. And we will be at dinner.
Yes.
All right. You can come to the table and quiz us all.
Diagnosis.
All right. So I think I should just say thank you for your attention. But Kerry's got a hand up. Okay, in 30 seconds. Okay, you're off the hook. So feel free to catch us now you've seen our faces and you have our email addresses. Enjoy the rest of the day. that the very last talk of the day?
That was the last talk of the day.
It's teasing. Don't get your ideas. Thank you.
Yep, take
And then we
yours.
probably should have this plugged in somewhere to keep it charged.
You guys into that.
Just like that, yes. Very good, very good. That's off. That's off. Ah, there's Batseba. Hi, Batseba. I can't hear you though. I think the sounds.
Hi, Anita.
Oh,
How are you?
Let me see if I can.
Hi, Anita. Good, I'm good, I'm good.
And change the sound. So the computer sound is. But I still don't hear you. Never mind. Nice to see your name, Seba. We've been looking after Tanya. Who is here? Sitting next to Moses. Do you know Moses Basatere? His colleague. And Moetsi from University of Free State. Cheerio.